3 seconds. That is your entire window when a missile traveling at Mach 15 enters its terminal dive toward a target. 3 seconds to detect it. 3 seconds to calculate the trajectory. 3 seconds to fire an interceptor that itself needs time to climb, acquire, and hit. For most of the history of missile warfare, defenders had minutes, sometimes tens of minutes. This conflict just changed that. Iran has confirmed the combat debut of the Fate 2, its most advanced hypersonic glide vehicle, fired against Israeli and American targets in what Tehran calls Operation SAD-DC Promise. 4. Fresh launch footage has been released. The missile is real. The flight is documented. And 2 questions now hang over every defense ministry in the region. Can anything stop it? And how many does Iran have? We're going to answer both. But first, you need to understand what this missile actually is. Because what the headlines are calling hypersonic barely captures what engineers spent a decade building into this system. The story of the Fate 2 doesn't start with this launch. It starts much earlier with a family of missiles that most Western analysts dismissed as incremental upgrades. They weren't. Stay with us, because by the end of this breakdown, the scale of what just shifted will be clear. To understand Fate 2, you need to go back to a missile with a glass nose. The Fate Mabin, unveiled in 2018, looked different from anything Iran had shown before. Not a sharp metal tip, but a slightly flattened nose with a small optical window. That window contained an image-matching seeker, a system that allows the missile to visually recognize and lock onto a target in its final descent. No GPS required. No radio signals, just sight. Western analysts noted it. The Washington Institute called it a shift in the power balance, but it was treated as a regional curiosity. What they missed is that the Fate Mabin was not a destination. It was a waypoint. It was the 4th or 5th evolution in the Fate 110 family, a deliberate generational weapons program that Iranian engineers had been refining for over a decade. Each generation improved range, guidance, stealth, and speed. But here is what changes everything. The Fate 2 doesn't just carry a better seeker, it carries a hypersonic glide vehicle warhead, a fundamentally different category of weapon. Traditional ballistic missiles arc predictably. Interceptors are calibrated to that arc. A glide vehicle abandons that arc entirely. It skims the upper atmosphere, maneuvering laterally, changing direction at speeds that defeat the computational assumptions baked into every existing defense system in the region. So, what does Mach 15 actually mean in practice? And does the Fate 2 actually reach it? The number matters less than the trajectory. And the trajectory is the problem. Mach 15 is roughly 11,400 miles per HR. A commercial aircraft flies at 550. An advanced fighter jet sustains Mach 2 for limited periods. Mach 15 is not a faster version of those things. It is a different category of physics entirely. At those speeds, the friction with the atmosphere generates temperatures that would melt conventional metals. Guidance electronics must survive that heat while remaining precise enough to steer. The aerodynamic forces acting on the vehicle change in ways that make standard control surfaces unreliable. Every system on the missile, propulsion, navigation, structure, must be engineered from scratch for these conditions. That is why only the United States, Russia, and China had credibly demonstrated operational hypersonic systems before this launch. Now there is a critical nuance here, and we will not hide it. Mach 15 refers to the terminal velocity, the peak speed during the final descent phase. The full flight profile of the Fate 2 is not uniformly hypersonic. It accelerates, glides, maneuvers, then dives. But that final phase, Mach 13 to 15 in the terminal approach, is precisely where defense interception must occur. And that is exactly where existing systems are most vulnerable. And this is where it escalates. The Fate 2's range is reported at 1,400 to 1,500 kilometers. That puts Israel, U.S. bases in the Gulf, and regional military infrastructure all within reach, from launch sites deep inside Iranian territory. Range and speed are one half of the threat equation. The other half is what happens when the defense network tries to respond, because Israel's defense layers were not built for this problem. Israel operates one of the most sophisticated layered missile defense networks ever built. Iron Dome intercepts short-range rockets with an impressive track record. David Sling handles medium-range ballistic threats. The Arrow system, Arrow 2 and Arrow 3, is designed to intercept long-range ballistic missiles, sometimes outside the atmosphere entirely. Every one of those systems was designed around a common assumption. The incoming threat follows a predictable arc. Ballistic missiles climb, peak, and descend on a trajectory that physics largely determines in advance. Defense computers use that predictability to calculate intercept solutions ahead of time. The Fate 2 violates that assumption structurally. A hypersonic glide vehicle does not follow a clean ballistic arc. It enters the upper atmosphere and then maneuvers, changing direction, shifting altitude, approaching from angles the defense geometry was not calibrated for. The radar sees something. The computer tries to model where it will be, but the missile's next position does not match the model. This is not a marginal performance gap. It is a targeting logic failure. The interceptor is launched toward where the threat should be. The threat is somewhere else. And at Mach 15, the margin for a second attempt is measured in fractions of a second. The United States has been investing in space-based hypersonic tracking sensors precisely because ground-based radar networks have this blind spot. Those systems are still maturing. And this conflict is happening now. But the defense gap is only part of the strategic picture. The other part is where Iran can launch from, and how many missiles they can put in the air. The platform story is just as important as the missile itself. One of the most underreported features of the Fate missile family is its launch platform flexibility. The Fate Mobin, the precursor, can be fired from mobile truck-mounted launchers. It can be concealed in standard commercial shipping containers and fired from any position along Iran's coastline or interior. The Fate 2, built on the same operational doctrine, inherits that mobility. That means there is no fixed silo to target, no identified launch site to strike preemptively. The launcher can be a truck parked behind a hill, repositioned after launch, and concealed within minutes. And crucially, the production line is entirely domestic, Iranian-designed, Iranian-manufactured, using locally sourced components. International sanctions have no pathway to interrupt the supply chain. The missiles can be produced continuously, stockpiled, and dispersed. Which brings us to the strategic dimension that governments across South Asia, the Gulf, and Europe are now recalculating. Because this isn't just about Israel, the radius of consequence is much wider. India imports between 60 and 80% of its oil from the Gulf region. Saudi Arabia, the UAE, Iraq. The supply lines run through waters that are now inside the operational range of Iranian missile systems. If the Strait of Hormuz closes, or if Houthi operations in the Red Sea intensify in coordination with Iranian escalation, that oil does not reach India, or Japan, or South Korea, or most of Europe. The Fate Mobin was specifically designed for Hormuz control scenarios, a short-range, precision system capable of hitting moving naval targets through infrared tracking, even in darkness, smoke, and electronic jamming environments. A destroyer moving in zigzags cannot outrun a missile, correcting its own flight path in real time. The Fate 2 extends that logic to a 1,500-kilometer radius. The targets are no longer just ships in the strait. They are ports, airfields, command infrastructure, and forward operating bases across the entire Gulf. What begins as a bilateral exchange between Iran and Israel is structurally a risk event for global energy markets, regional military alliances, and every government that depends on Gulf stability. Analysts in New Delhi, Riyadh, Ankara, and Brussels are not watching this as a distant conflict. They are running contingency scenarios. And here is what makes the next phase so difficult to predict. Because the escalation ladder now has a rung that didn't exist 6 months ago. Here is what we know with confidence. Iran has demonstrated a hypersonic glide vehicle in active combat. The system works at a threshold that existing regional defenses were not designed to counter. The launcher is mobile, and the production is sanctions-proof. Here is what remains uncertain: the size of Iran's operational Fate 2 stockpile, whether the guidance precision in combat conditions matched the test parameters, how quickly the United States can field space-based hypersonic tracking sensors that could close Israel's interception window. And here is the strategic reality that sits underneath all of it. The introduction of hypersonic weapons into an active regional conflict is not an endpoint. It is a forcing function. Every government in the region now faces a defense investment decision. It cannot defer. Every military planner must revise threat assumptions that were settled doctrine 6 months ago. Every diplomatic channel now carries a new variable. The Fate 2's first combat flight was not just a weapons test. It was a message about what the next phase of this conflict could look like. Delivered at Mach 15, the story doesn't end with this launch. Every test, every escalation, every defense adaptation feeds back into a strategic cycle that is accelerating. And the next development in that cycle may already be in motion.